When dealing with a distribution panel operating at 480 volts, 380Y/220 volts and feeding three identical branch circuit loads each drawing tank VA connected line to ground at 220 volts, the method for determining the appropriate size of the main overcurrent protective device, or OCPD, is as follows. The fundamental principle here is understanding the relationship between voltage, current, and power in alternating current circuits, specifically in relation to single-phase and three-phase configurations. Firstly, let's clarify why the square root of 3, or approximately 1.732, is not required in this calculation. This factor is essential when dealing with three-phase power calculations, specifically when voltage and current are measured line to line. However, in this scenario, the loads are connected line to ground, effectively making them single-phase 220 volts loads. Therefore, the square root of 3 is not applicable. Secondly, to calculate the current drawn by each tank VA load, we use the basic power formula, which is power equals voltage times current. In this case, we need to rearrange the formula to solve for current, so current equals power divided by voltage. For each load, this translates to 10,000 volt amps divided by 220 volts, resulting in 45.45 amps. This 45.45 amps represents the current flowing through each of the three identical branch circuits. Thirdly, the key point to understand is that because each load is connected line to ground, the line current is equal to the phase current. In a line to ground configuration, each load is essentially a single phase load connected between one of the phase lines and the neutral, or ground. The current flows from the phase line through the load and back to the source through the neutral. Therefore, no vector addition or phase angle considerations, which necessitate the square root of 3 in three-phase calculations, are needed. Fourthly, determining the size of the main OCPD requires considering the total load on the panel. Since there are three identical loads each drawing 45.45 amps, the total current is 3 times 45.45 amps, which equals 136.35 amps. The main OCPD must be sized to protect the panel's main conductors from overcurrent conditions. Fifthly, the National Electrical Code, or NEC, provides guidelines for selecting the appropriate size of overcurrent protection devices. It is crucial to consult the NEC to ensure compliance with safety standards and regulations. The NEC typically requires that the OCPD be sized to carry the calculated load current plus any applicable directing factors or adjustments for continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. If the loads are considered continuous, the NEC requires that the OCPD be rated for at least 125% of the continuous load current. Sixthly, assuming the loads are non-continuous, the minimum size of the OCPD would be slightly above 136.35 amps. In practice, standard OCPD sizes are used, such as 150 amps, 175 amps, 200 amps, and so on. The next highest standard size above 136.35 amps would be the minimum acceptable size. However, if the loads are continuous, the calculation changes. To account for the 125% requirement for continuous loads, we multiply the total current of 136.35 amps by 1.25, resulting in 170.44 amps. In this case, the minimum standard OCPD size would need to be above 170.44 amps, such as a 175 amp or 200 amp breaker. Seventhly, it is important to consider the ampacity of the conductors feeding the panel. The conductors must be sized to carry the calculated load current, and the OCPD must be sized to protect the conductors from overcurrent conditions. The NEC provides tables such as NEC Table 310.13b16 that specify the ampacity of conductors based on their size, insulation type, and installation conditions. The OCPD should never be larger than the ampacity of the conductors it is protecting unless specific exceptions outlined in the NEC apply. Eighthly, when selecting the OCPD, it is essential to consider the interrupting rating of the device. The interrupting rating is the maximum fault current that the OCPD can safely interrupt without failing. The available fault current at the panel must be determined, and the opt must have an interrupting rating equal to or greater than the available fault current. A qualified electrical engineer or electrician can perform a fault current study to determine the available fault current at the panel. Ninthly, in summary, to size the main opt for 3 10 loads connected line to ground at 220 volts on a 480 volts 380Y/220 volt system, the following steps should be taken. 1. Calculate the current drawn by each load by dividing the power in volt amps by the voltage. In this case, 10,000 volt amps divided by 220 volts equals 45.45 amps. 2. Determine the total current by multiplying the current per load by the number of loads. In this case, 45.45 amps times 3 equals 136.35 amps. 3. Determine whether the loads are continuous or non-continuous. If the loads are continuous, multiply the total current by 1.25. 4. Select an opt with a rating equal to or greater than the calculated current, taking into account whether the loads are continuous or non-continuous. 5. Ensure that the ampacity of the conductors feeding the panel is equal to or greater than the rating of the opt. 6. Verify that the interrupting rating of the opt is equal to or greater than the available fault current at the panel. 10thly, it is critical to consult with a qualified electrical engineer or licensed electrician to ensure that the opt is properly sized and installed in accordance with all applicable codes and regulations. Incorrectly sized overcurrent protection can lead to equipment damage, electrical fires, and other safety hazards. The NEC is updated regularly, so it is important to stay current with the latest requirement. Lastly, to reiterate, the multiplying factor of 1.732, which is the square root of 3, is not required in this scenario because the loads are connected line to ground. This factor is only applicable when dealing with 3-phase loads connected line to line. By understanding the principles of single-phase and 3-phase power calculations and following the guidelines provided in the NEC, one can accurately determine the appropriate size of the main opt for these loads. The main opt for these loads should be sized at approximately 45.45 amps per phase, totaling around 136.35 amps for all 3 phases, but the opt should be selected based on standard sizes and adjusted according to whether the load is continuous or not, the conductor ampacity, and the available fault current, as per the NEC guidelines.